Welcome to another exciting week. I hope you all are having a lot of fun. It's been a pleasure for me taking you on this exciting journey. Some housekeeping. If you have any difficulties, help is available. Make sure you reach out to me, email me, call me, or text me. I want you to know that you are not alone. We are on this journey together. And it is my desire and wish for you that you're going to do well. We have another exciting week ahead of us, and I want to make sure that you are having the most out of this class. Last week we looked at igneous activity. We described what magma was and what lava is. When molten rock is below the earth, it's called magma. When it comes out on the surface, it's lava. We looked at 3 different types of igneous rocks. This is influenced by the silica content. We have the felsic, which are high in silica. We have the mafic and the intermediate. These 3 different types of igneous rocks behave differently when they come out on the surface of the earth. This week we're looking at volcanoes and volcanic activity. It all deals with what happens when lava cools and solidifies on the surface of the earth. The 3 different types of lava are going to cool and solidify differently, and they will also produce different types of volcanic edifices or different types of volcanoes. One other term that was introduced last week was viscosity. It simply means the resistance to flow. Your mafic lavas are why the intermediate lavas compared to the mafics, they are going to flow with some difficulties. The most fluid lavas are your mafic lavas. These ones have the ability to cool and solidify and form shield volcanoes. These are the type of volcanoes that have very broad bases, but their heights are not very impressive. We also have ash and cinder cones that are formed as a result of very violent eruptions. Now that I'm talking about the type of eruptions that are related to these different types of lavas. Your felsic lavas are usually involved in violent eruptions, and the mafics are more quieter, although one of the determining factors is the amount of gas that you have in the lava. The more the gas content, the more explosive the eruption is going to be. Picture soda in a can and all the CO2 that you have in that soda. When you shake the can and you open it, you see how explosive that can be. Some of these lavas as well, they have a lot of CO2 in them. Some have H2S and some have water as well. When the magma is below the earth, it's under high pressure. This pressure keeps in the gases. When this lava comes out, the pressure is released and the gases will come out. Remember the textures that we saw, the vesicular textures, which is a direct result of the escape of gases from the lavas. Our volcanoes are going to be located predominantly on the active plate margins, the subduction margins. The only intraplate volcanoes we're going to find are those hotspots, for example what we have in Hawaii, and also at the spreading centers where we have upwelling of magma from the mantle. It is going to be an exciting week. Volcanoes have a lot of benefits associated with them because volcanic soils are very rich. We're going to be looking at all that. I expect you again to participate on the discussion board. Make sure you answer the question for the week and also respond to at least one other post from one of your course mates. If you have any questions, you have any difficulties, don't hesitate to reach out to me. Don't hesitate to let me know. Thank you, and let's have a wonderful week.